Hey all, terrible video quality, but my the webcam on my laptop is not a good one. But anyways, I wanted to just give you a quick talk through of this week's assignment where you're going to be analyzing some temperature data from different stations across the Western United States. They're kind of regional, I guess. Um, I've got a kind of approved list, and that approved list is not cherry picked. Those are the stations where an individual station essentially has, the majority of what we would call the instrumental records. So going back to, roughly 1800. Um, there are some stations where there's composite, like 3 different data sets for the same location, and I just thought it'd be easier to go ahead and do this. So I'm going to share my screen here, and whoa, what am I going to share my screen? Let's see. Here we go. Your assignment's going to look a little bit different than this, but I wanted to show you kind of how to get there. So when you open your assignment, there's going to be a link. So you can just kind of digitally click on that. I think control click will allow you to follow the link. And it's going to take you to a website that looks like this. So let's bump over to that website. I think I've got to do a new screen share to do that. Okay, here we go. I had a whole bunch of windows open up here. So this is the NASA website. It actually has a lot of information on it. We're going to go ahead and look down at climate stations or weather stations. So if you look here, you'll click in the station data tab. That's going to open this window. It's got some data in here that includes, all of the stations. But if you scroll down, there's actually a map that shows all of the stations where you can download data, scattered out here through the Pacific Islands, a bunch in Hawaii. Obviously, the contiguous United States, pretty saturated. There's a lot of people. Places that are less sparsely populated, harder to get to. We don't have as much data. We're in the middle of the Amazon, in Siberia, Central Africa. So you could go ahead and navigate to your own station, using your kind of roller wheel on your mouse. But actually, what we're going to go ahead and do is just type in a station name here from the list. You can just copy and paste them, and it'll bring up the data that you're looking for. So here, I picked one at random. This one's not in the data set. But first of all, you can see this wiggly line that's going to show you essentially the temperature records. And also notice that there are a few gaps. We're going to deal with gaps in data. This is actually not what we're going to do. We're going to create one ourselves using Excel. So if I scroll down, I can actually download monthly data as text or CSV. You want to go ahead and do CSV because Excel can recognize that as a data file. So I'm going to go ahead and open that CSV file. Each time you change programs, you got to do a new screen share. Okay, so here we are. This is the data. It's just a whole bunch of numbers. It's in Celsius, because that's, the SI unit for temperature. And notice that in my data set, there are a bunch of these cells that are marked 999.9. That's essentially missing or corrupted data. So what we're going to go ahead and do is we're going to get rid of those first. So the trick here is if you hold the control button and press F, that's find. So we're going to open the find and replace function. There's probably a different shortcut if you're using a Mac, so I apologize. I'm not sure what the shortcut is there. I think maybe Command F. I'm not sure. So 999.9. And I notice I opened the replace tab, and I'm leaving the replace cell empty. And I'm going to go ahead and click replace all. And it looks like we made 29 replacements, and it actually just deleted those cells for us. So now if we look at our data, we've got, cells deleted where they need to be, and we've got our temperature data. But what we're going to do is we're actually going to be making a graph and looking at how these temperature trends have changed over time. So notice in this far right column, you have one titled MET AN. And that's actually the average annual temperature for that year. So basically the high and low each day kind of averaged through the month, averaged through the year. And so this first cell, 1984, like I said, the data set I selected is pretty short. So this would be 8.4 degrees Celsius as an average annual air temperature, which remember, that's the kind of the high during the day and the low during the night. And water freezes at 0 degrees Celsius. So these numbers you might not be totally familiar with. So just to make this data more palatable, the first thing that we're going to do is actually convert this to Fahrenheit. So it's a number that you're more familiar with. And to do that, we're going to enter a formula in Excel. So Excel is, once you figure Excel out, it's actually not very complicated, but it's tricky, right? You got to put the formula in exactly as it says. So notice when I click on the cell, I can either do that here, or with that cell highlighted, I can go up here and enter it. I'm more comfortable entering it in the cell. So what I'm going to do is I'm going to convert Celsius to Fahrenheit. So I have to enter an equals sign that knows that that's like code, right? So Excel knows that I'm going to enter a formula, and I'm going to write the word convert. So I'm going to convert, and then I can actually go and click on the cell that I want to convert. So notice it's showing it there in blue, cell R3. Yours may be different, but it actually should be column R. And then I'll go ahead and put a comma, and then I'm going to open a quotation mark, capital letter C, close that quotation mark. Let's see, I've moved my little screen here. Okay, capital letter C, open quotation, capital letter F, close quotation, and then close my parentheses, right? So notice that I put that whole formula after the word convert in parentheses. So now Excel knows what to do. And if I press enter, I've now converted that to temperature in Fahrenheit. So here for 1984, this, I think the data I picked was Page, Arizona. The average annual air temperature is 47.12 degrees Fahrenheit. Okay, great. So we're building our temperature record. The next thing that we want to do is actually do that to every year. But Excel lets you do this in a cheating shortcut sort of way. So notice my cursor, as I hover over this little green box in the corner, it turns into a black plus sign as opposed to an open plus sign that you see here. So when I click and it's a closed black plus sign, I can actually double click on my mouse and it will autofill that column for me. And so now, yay, Excel did my work for me. Now I have average annual temperature for all of these individual years, with the exception of this year. So in this case, there was no data in the average annual temperature. 1993 must have been a terrible year. So I'm going to go ahead and just delete that cell. Just hover over it, hit the delete key, it blanks it out, and there I go, right? So now I have this column here in column S of my average annual air temperature in Fahrenheit. So it's a number that's easy for us to think about. And we've got a couple more things to do here, and we're going to enter another equation. So we want to figure out, okay, from 1984, 1983, whenever my record started, to today, what's the average temperature for any given year? What's the average ambient air temperature, not just of any year, of all the years, right? So that'll provide us a great baseline to kind of analyze our other data. Are we greater than average? Are we less than average? So to do that, I'm going to actually follow some of the same things I had done before. So I'll click in my little cell here. I'm going to hit the equals key because we're entering an equation and Excel needs to know that. I'm going to write the word average. And then I'm going to open some parentheses as we did before. And then I'm going to click on this cell and I'm going to hold my cursor down, kind of hold my click, I guess. So I'm going to click and drag until I've highlighted that entire column. And then when I let go, I'm going to close the parenthesis, which you can see here. And then I'm going to press enter. And now I've got an average temperature. It's got too many decimal places. That won't matter for you, but it's nitpicky thing for me. So I'm going to go ahead and chop those decimals down. So 48.2 degrees is our average. Cool, right? So now we've got a weather station, we've looked at all the data, converted it to Fahrenheit, and we've now figured out what the average temperature over that period of time is for that station. So I want to graph that, right? And that's the first thing that I want to go ahead and do. So this is a little bit tricky. So again, make sure that you're following along in the video here. And if you get lost, hopefully you can rewatch the video, or figure out how to make my little face larger. There we go. All right, now I feel like I'm talking to you. Okay, so I am a big fan of keyboard shortcuts. You might not necessarily be, but I think they make especially work in Excel so much more easy. So I've got my cell highlighted here. I'm going to go ahead and hit Control C. That is going to copy that cell, and it looks like there's little ants marching around it. That's how I know it got copied. And then I'm going to go up here, and this is a little bit of a tricky part. I want to make sure that you go ahead and do this correctly. So that cell is generated from a formula, right? We use the average formula. So if I copy that cell up here, it's actually just going to copy the formula, and that's not what we want. So we just want the numbers. So you could either just manually type the number in, or you can right-click on the cell that you're interested in. And notice that there's some options here. Paste options, paste regular paste, paste values, paste formula, all that stuff. We're going to go with the clipboard 1, 2, 3, the old paste values command. And I'll do that, and actually just copied over the raw number itself. So it didn't bring any formulas or anything like that with it. So that number isn't going to change through our data set, right? That's the average of our whole data set. So I could, again, kind of highlight over. So I've got my little black plus sign, and double click that bad boy. And it's actually going to fill that number in for every year, because that value, the overall average, is true for every year. Okay, so now let's see what this looks like, right? Let's graph this. And I'm not sure how the editing is going to work out in this, so should be pretty straightforward by the time this makes it to you. I may have chopped this video up in a few pieces just to make it a little more palatable, or maybe I put the whole thing on there. I don't know. I'll try to be less chatty, just kind of more to the business. Okay, so we're going to go ahead and add a graph. And again, I know that you guys probably are coming at this with a variable experience in Excel, but I'm going to kind of pretend that you've never really used Excel before. So if we go ahead and ask Excel to make a graph for us, it's going to try to guess, and it's going to guess wrong every time, right? That's just what Excel does. So to avoid that, you can go ahead and just select. Notice that I selected a cell out here that's not next to any data. It's just off floating in the ocean somewhere. If you do that, Excel won't guess. It's kind of a hack in a way. I'm kind of a hack when it comes to Excel, that's for sure. All right, so we're going to go ahead and insert. So I'm going to click on the Insert tab here at the top. Insert. And if you look, there's a whole bunch of different charts that we could pick. Almost always in the sciences, we're using some sort of line graph or like XY data, and that's what we're going to be doing here. So I'm going to open this thing. There's a couple of options. I could have a bunch of dots. I could have some dots connected with lines. I'm going to go ahead and just pick these clean angular lines, the ones that show a rounded pattern. They'll smooth your data. That's not what we want. We want to just look at the data itself. So I'm going to go ahead and select that. It's called scatter with straight lines. And the next problem is we just got a blank square. That's not very useful. We need to put data in it, or tell Excel what data to put in it. So to do that, we can right click. And again, if you're using a Mac, I'm a little dicey on Mac Excel, I don't use one, so I'm not sure of all of the shortcuts. You might it might be easier if you just hop on a PC at school or something like that. But anyways, I'm going to go ahead and right click on this cell or this blank area. Notice that because I have it selected, here it's not selected, here it's selected. You can tell the difference because the little picture frame shows up, and those little dots let me know that I'm active in that space. So I'll right click on there. Gives us a whole bunch of options. This is the one that we're interested in, select data. So I'm going to go ahead and do that. And then I could call it, I could give it a name. It doesn't really matter. I'm going to go ahead and click add. Series name, let's call it average temp. Okay, average temp overall, because we're actually going to look at the average of a subset. So it'll be nice to have those separate. So what do we want for our X values? This is the part of the graph that goes across the bottom. Well, in the sciences, we use our independent variable, right? So essentially the constant. So we're going to go ahead and use our time. So I've got my cursor here, series X values. I'm going to go ahead and click on this 1983, and I'm going to hold that down, and I'm going to click and drag my entire temperature, or my entire year column, excuse me. So I'll click down. If you do it, if you pull down really hard with your mouse, it'll go all the way to the bottom of the page. So you kind of have to throttle it, which is really interesting. Okay, so I got my data. And now I'm going to take my mouse and I'm going to go into the next cell, which is series Y values. And this is something I learned in undergraduate. That's the devil in Excel. The devil's in the details, right? And in this case, one of those details is this number 1 that's sitting in here in these brackets. We don't want that. It's just there to like meet the rules of math. So I'm going to go ahead and I'm going to backspace and get rid of that, but I'm leaving my equals sign because, again, that's pretty important. I can scroll up to the top. You can do bottom to the top, top down, doesn't really matter. And I'm going to go ahead and select my data. And in this case, the value is going to be boring. It's the same value for every year. And as you can guess, it's just going to plot a straight line. So I get to the bottom, I let go, I click OK, I click OK, and now I can look at my average temperature overall. It's total snooze fest, right? This thing is pretty boring. And also my graph is kind of extending beyond my beyond what I want here. So actually, depending on how I don't know, OCD you are, I'm pretty OCD when it comes to Excel because I know that if things go wrong. So I can click on that and format axis. You don't necessarily have to do this. It tells me the top and the bottom of my axis. It goes from 1980 to 2025. Well, I think my record starts in 1983. So I'm going to go ahead and enter 83. This is an optional step. And it's 2021. So put that in there. And now my graph matches my data. I'm a little bit happier. We're going to do the same thing for the vertical axis, but I want to wait until we see kind of what we're up against. Okay, so I'm going to clear this little window out here. And now, well, our graph isn't showing us much, right? It's showing us this average temperature. We're going to go ahead and at this point, we're going to add this column that we had calculated earlier. So we're going to look at the individual temperatures in Fahrenheit per year. So to do that, I can, again, highlight my graph. Notice it has the little box around it. The little dots are there. I'm going to go ahead and right click and I'm going to select data again. So there's already a data set on this graph. It's showing it here, but we want more. We're going to have a couple of them, right? So let's go ahead and add data in this case. It's going to ask us the same thing. And I actually just gave it an temp. This sounds like someone's name, but whatever. And the first step is going to be the same. Click in the series X values. Go ahead and click and drag for your years. And then series Y values, the devil, right? We got to get rid of this number 1. But in this case, I'm not going to use my averages. I'm going to use the column that we converted to Fahrenheit. So I'm going to go ahead and click on this first one, which looks like it's 1984. And I'm going to drag down. When I get to the bottom, I'm really careful not to include that bottom cell because that was our average, right? So that's actually not part of our record. I'm going to let go. I'm going to press OK. I'm going to press OK. And now I can go up and I've got this beautiful graph here showing me annual temperature overprinted with the average annual temperature. And that's pretty useful, right? And so you're going to have some questions based on that. And so here we've got the values for each year, and then we've got our overall average. I want to do just some quick analysis and see which or how many of those years exceed the average and how many of them are below the average. It should come out to be 50-50. So to do that, again, I'm going to go ahead and I'm going to enter a formula. So equals sign, and we're just going to do some simple math. So I'm going to take, well, if you watch what I'm doing here, I'm going to click cell S3, which is the value for that individual year, in this case, 1984. And I'm going to subtract this next cell, which you can see is the value that was our total average. Okay, so entering a formula in Excel, we're just going to do a simple subtraction here. We're going to see, we're going to subtract the average from the value. If that's a negative number, that means it was below the value. If it's a positive number, so on, right? You got it figured out. So I'm going to go ahead and click here on this cell. This is the annual temperature for, we'll move this over, for 1984. So I put in equals. I'm going to take my year data. Looks like that's now shown here. And I'm going to put the subtract sign in there. I'm going to click on the next thing. And so now I have cell S3 minus cell T3. I'm going to hit enter. Surprise, that's a negative number. That means that year was below average. And so again, now I'm going to do a trick that hopefully you've really started to appreciate. I'm going to hover over that little corner and I'm going to double click that guy. And I've got all of my temperatures show, or all of my kind of variance from that average shown here. So Excel does a lot of things for you. It could do this next step for you if you write an if-then formula. Those are kind of level 2 Excel, so let's go ahead and skip those. But what I want you to do is to go ahead and you can just put the cursor here. You can drive it around with the keys on your keyboard, you know, the arrow, the directional keys. And for each value that's not a negative number, which means that was above the average, I want you to go ahead and enter the number 1. And for the others, you can go ahead and leave them blank. So if you look here, I'm going to scroll down. Looks like these are all negative. Oh, here's a positive number. Here's a positive number. You know, try not to miss any. Notice I'm kind of scribbling through here. Okay, so I could actually even sum those if you want and see. You can go all the way back to the column. It looks like in my case, I had 19 years that were above average in my record, which is probably just about 40 years. So roughly half, which is what we would want. But then I'm going to have you go ahead and look at how many of those years in a more recent time period exceed that average. So again, our average temperatures are calculated on a rolling 30-year basis. So I want you to go back to essentially the year 1990 in your record. I could do that here. That's basically the beginning of my record. Because like I said, my data set's pretty small. And I want you to figure out how many times since 1990, your temperature record or your annual temperature exceeded your average. So that'll be one of the deliverables. And then the second thing that we're going to do is we're going to keep that in mind, right? So we're going to keep in mind this notion that average temperature is something that we calculate in a rolling 30-year basis. So let's go ahead and take a new average of the last 30 years. I'm going to go ahead and actually, I don't have that much data, so I'm going to do it just for the last 10 years, 2010, but the process is the same. So again, I've got my cell down here. I'll click enter. I'm going to write the word average. I'm going to open those parentheses. I'm going to go over to my 2010 year, which is right here. Click and drag. I didn't select that one that I had already there because I don't want to click that average. Close parentheses, hit enter, and okay, here we go. So this is my new temperature average. 48.9 degrees. And then we're going to do basically what we had done before. I'm going to go ahead and take that 48.9 degrees. I'm going to copy it. I'm going to paste it over according. So here's my 2010 column. You can double check here. And I'm going to paste values. And then I'm going to drag that information down. And so now I have this new average, which is just this last chunk of yours. Yours is going to be longer. Mine's pretty short. Your data sets are also going to be much longer. And then just as we had done before, I'm going to go ahead and select data. I'm going to add 2010 to 2021. X values are going to be, just as we said, 2010 to 2021. The Y values, we're just going to be putting in another flat line, right? So the Y values here are that new average. Okay and okay. And so now we've got this new temperature average that's showing how what's the average temperature for the kind of more recent time period. And you're going to have some questions in your assignment about this. Okay, so the next thing that we're going to do is we're going to kind of dip into very, very, very like level 1 or maybe level 0.5 simple climate modeling. And that's going to require us to put trend lines in our data. It's actually pretty simple. It sounds complicated, but it is, yeah, it's like 7th grade math. I know that 7th grade was oftentimes a long time ago, so I'll walk you through it. So I'm going to go ahead and create a trend line. So notice I clicked on my data. It highlights some of it. And if I right click on just kind of on the line somewhere, it's going to give me the option to format the data series. I can make it any color I want, but I'm actually going to go to add trend line. So we're going to add a trend line. There's a couple of different options for types of lines. I'm going to go ahead and just do an overall linear trend, which means it's going to give us a straight line that goes through the trend of our data. And then the most important thing is actually we're going to display the equation on the chart. So I clicked that little box, and it actually gave me this cool little equation here. So that's great. Let's see if we can. Well, I was going to make it a little bit bigger, but you guys get the point. So it looks like the equation for my line is y equals 0.0655x minus 83.065. Y equals mx plus b. It's the slope of a line, right? And so the cool thing about that is you can actually input values and you get an answer, right? So a graph is an equation, or a line is an equation. So what I want you to do is I want you to, looking at this trend of data, I want you to look forward to a different year and see what the projected temperature if this linear trend continues. There's a lot of assumptions there. Like I said, this is, we're just kind of playing with the numbers. So remember that this is your x-axis on the bottom, and your y-axis is this vertical one. So actually, if we want a y value, all we have to do is pick an x. That in this case, that can be a year. So I'm going to go ahead. You can do this on a piece of paper or scribble this out. I'm going to do it in Excel because I'm fairly comfortable doing that. But I'm going to write y equals. So I'm just going to do the equals sign. And let's see, what did I have? Well, I'm going to open some parentheses, 0.0655 times the asterisk symbol. And let's pick a year in the future. Let's pick 2100. Right, so that's 80, a little bit less than 80 years into the future. I'm going to close my parentheses, then I'm going to write the rest of my equation, which was negative 83.065. And then when I click enter, I'll have the temperature if that line were to continue, if that makes sense. So it looks like the average or the annual temperature predicted for the year 2100, just looking at this trend that I have here, is 54.4 degrees, which is far higher than either of our averages, right? So actually, I'm going to go ahead and copy that, put it over here. So 54.485. That's significant, right? That's about 6 degrees higher than our overall average, and just about 5 degrees higher than our kind of new, kind of more recent average. So we're going to do this one more time, and that'll be the end of the assignment. So we're going to get a little bit tricky here. So there's, again, multiple ways to do this, but what we can do is I'm going to go ahead and I'm going to take my subset of years. So I took 2010 to 2021. I'm actually just going to hit Control C. I'm going to copy that. So just to make this easier to understand, I'm going to do a Control V, paste that here. So I chopped out a chunk of years, but it didn't get rid of the years. I didn't cut it out of there. And then I'm going to take those temperature averages, the annual average from those same years, which was, I got a lot going on here. 2100, or yeah, 2010, excuse me, not 2100. I'm going to take that temperature data, being careful not to grab any of my averages, Control C, copy that bad boy. And then I'm going to Control V, but because that's a calculated column, I need to just do paste values, which, like I said, avoids lots of trouble that Excel likes to make. Okay, so here, I'm actually going to take this data and I'm going to plot it again. It's going to be boring because it's actually going to plot directly on top of the data that you already have, but it's going to give us a chance to calculate a new trend line and provide a new round of modeling. Okay, so let's go ahead and do that. So I'm going to go to my graph. Here, I'm actually going to scoot my graph down so you guys can follow along without all those numbers in the background. So I'm going to go ahead and select data, add. So this is 2100 or 2010 to 2021 temp. X values are going to be the years. Y values, you got to get rid of that one, are going to be the temperature. And we don't see any change at all. Actually, we do see a little bit of change. It's showing that in a separate color because it's kind of overlaying. Okay. So now we've got this second subset. So I can click on that data set. And this is why we had done this. And I'm going to right click and add a trend line just as we had done before. I picked linear. I'm going to display equation on chart. And now I've got a new equation. I'm going to put this one down here so that I don't get lost. And notice that the trend line that this one shows is much steeper, which suggests to me, just looking at the data, that the temperature trend of the last, in my case, I just did 10 years, is much steeper than the overall temperature trend. So following the kind of outline that I had done before, I'm going to do a very similar thing. So here, this number, 54.5, remember that was the predicted temperature for 2100 using my overall trend. We're going to do the same thing again using this shorter average that's just kind of recent years, or a recent average. Again, my data set's tiny, so my numbers are going to be a little bit more goofy. But you remember how to do this. I hit enter or equal sign just to let it know that I want to solve an equation. I'm going to open some parentheses. My new slope is 0.1587. And then I'm going to multiply that by the x that I'm interested in, which is 2100. Close the parentheses. And then the slope is minus 270.87. So I'll hit enter. And actually, this gives me a new temperature value, which is significantly higher, right? It's nearly 8 degrees higher than my previous temperature. And so what that suggests is that warming, or just looking at raw temperature, warming is happening at an accelerated rate, the kind of when we look at recent history. So you're going to have an assignment sheet, an assignment, like a digital assignment that you'll click through where you'll enter this data. And that'll be your assignment for this week. There also will be kind of a short bit where you have to write about it. But okay, well, this should get you through the guts of the Excel portion, which again, I know can feel a little bit uncomfortable. Hopefully I answered everything in the videos. If not, please shoot me an email. I can update this, or I can send out class announcements, help people in places where they potentially could kind of come unplugged. All right, so let's go to, we're going to go to stop share so I can be back. Okay, we're here back in the real world. You can see that it's near Halloween, right? My children have demanded that the house be decorated for Halloween. So hopefully that doesn't get too dated. Okay, all right, well, I'm going to go ahead and stop this, and good luck with your assignment. All right, bye.